Hi there, do now number 3. And we're going to do a little bit of practicing of putting recurring decimals into fractions in their simplest form as well. Now, the little dot above here means it's recurring, so remember, this number is really 0.8888, etc, 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 forever. This one is 0.544444, etc, etc. Only the 4 is recurring because that's the only bit with the dot above it. This one, though, would be 2.131313, etc, etc, etc. Both numbers are recurring. Both numbers are recurring because they've both got dots. They're dotty, like me. Okay, you've got 5 minutes. Please do have a go at this. Don't leave any stone or fraction or recurring decimal unturned. Off you go. 5 minutes starts now. Dun, 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 dun. last. Let's go. Right, first thing, there's quite a system to these. And the first thing is to just write x equals your number. So x equals 0.8 recurring. And remember what this means. This means that these 8s keep going forever in a pattern. Right, we need a second number where we have the same recurring decimals in the same place, but we're going to shift it at least one place bigger. In fact, if I times it by 10, it will be 8 will be this side of the decimal point, but there'll still be the same amount of 8s after this, right? There's not a gap at the end because they're infinite. It's recurring. So I have now made my number 10 times bigger. Right. I can take one number away from the other. I'm going to subtract, okay? Now, usually I do the top one, take away the bottom one, but actually I'm just going to look for the big one, take away the small one here. Because each of the 8s after this, if you visualize all of these 8s, each one has a partner in the other number. So when I subtract one from the other, all the recurring bits disappear completely. 8 take away 8, 8 take away 8, 8 take away 8, 8 take away 8, etc. Right? Now, except for this one where there's 8 take away 0, which leaves 8. 10x take away x leaves 9x. And neatly, all of that recurring stuff has disappeared. So x is equal to 8 divided by 9. I've just divided by 9 from here to get x, okay? That is what my number is. This number equals 8 divided by 9. Write as a fraction in its simplest terms again, so 0.54444444. Again, same thing. Start by writing your number down. There we go, just as x equals that number. Okay, now, here's the important bit. You really need to have your recurring part, so from the 4s onwards, just behind the decimal point. So the first thing I'm going to do here is times it by 10. I'm going to move it one place bigger. So it's 5.4 recurring. All the decimal places are now, the recurring bits, sorry, are now just after the decimal point. That's important. It saves time later on. It makes it easier. Okay, now I need my second number with the same recurring decimals in the same place, so 0.4 recurring. So if I make it, times it by 10 again, so now we're up to 100x because I've times it by 10 again. Oops. And if I times it by 10 again, it will now be 54.4 recurring. Okay, so I times it by 10 once to get that recurring decimal just after the decimal point. I then times it by 10 again to get a second number with the same recurring decimal after the decimal point. Again, there's no gap at the end of the one I've made bigger because there's an infinite amount of 4s. Okay, then subtract one from the other. Always do the big one, take away the small one, right? Or recurring, well, 0.4 recurring, take away 0.4 recurring, will leave nothing after that. The 4 take away the 5, or rather, let's think of it like this. 54 take away 5 is 49. So I've done the big one, take away the small one. 100x take away 10x leaves 90x. Okay, once you've got to that point, it's much simpler. It's much neater. There's none of this recurring stuff. I just need to divide by 90. So I have 49 over 90, and then see if I can simplify. The top one will divide by 7. In fact, that's the only thing that will divide it. And the bottom one doesn't divide by 7, so 49 over 90 is correct. 0.54 recurring is equal to 49 over 90. Right, that's one answer. Second answer. Next one. Okay, again, same thing every time. X equals my number. 2.13 recurring, and they're both recurring. 1, 3, 1, 3, 1, 3, 1, 3. Okay, now that number's fine, actually. That's my base point, isn't it? Because just after the decimal point, my recurring digit starts. So that's fine. I just need a second number now with the same recurring digits in the same place. I don't want it to be... If I shifted it one place, right? Let's imagine I times it by 10. I would have 21.313131. You know, if you only shift it one place, my digits would be out of line. So I need to shift it two places. because there are 2 recurring digits. So that's timesing it by 100 to get 213.13131313. Right? It's important that they match up. Otherwise, the next step, the subtracting phase, won't work, because I need to have 1 take away 1 leaves nothing, 3 take away 3 leaves nothing, and so on. On the other side of the decimal point, sorry, on the other side of the decimal point, I've got 213, take away 2 leaves 211. And over here on the other side of the equal sign, I've got 100x, take away 1x, leaves 99x. There's probably some joke about I've got 99 problems, but the x isn't one of them. Probably. I don't know. I don't really know what I'm talking about there. Then divide by 99. 211 divided by 99. Okay, now that will simplify because it's a top-heavy fraction. How many 99s go into that? Well, 2 99s go into that because that's 198, which leaves 13 bits left over. So 13 over 99, and then just have a quick double check that that's not going to simplify any further, and it doesn't. So happy days. Yeah. So just doing a quick double check on here. By on here I mean calculator. But that's right. I knew I was right anyway. But anyway, right. So have fun. Into the lesson you go. Off you go. Time for a lesson. Bye bye.